Great. So Soomeen, are you ready if I introduce?
Yeah.
Okay. Everyone, it's my pleasure to introduce Soomeen Hahm. She's faculty at SCI-Arc with William I. Kumaran. She teaches, I think, all of the programs. You can correct me. Undergrad, graduate, and then some electives that I think even postgrad can join. So we have both Edge students and MArch2 in IDD. And Soomeen will be one of our 2GAX instructors. So for the MArch2s going into design studio in a few weeks, Soomeen will be one of the instructors. So this is like a little intro chat. She's going to tell us about her work for about 30 minutes or so, and then we have time for some questions afterwards. So I think Soomeen came to SCI-Arc, was it 2 years ago now?
1.5.
One and a half, yeah, from the Bartlett and from the AA. So I'm sure she'll tell us a little bit more about that as well. So welcome, Soomeen. Thank you so much for joining us.
Yeah, thank you, Rachel, and really nice to meet you, everybody. Very excited to meet you all soon. Yeah, in person. Yeah. Yeah, my name is Soomeen. As Rachel introduced, I joined SCI-Arc 2020 January, and then the pandemic started after 2 months. Yeah. But yeah, it has been a great experience. And previously, I graduated from Architectural Associate from London. And after that, I worked for Zaha Hadid Architects for several years and taught in AA and Bartlett UCL. So today I'm going to show some of my work that we are developing in our practice, and some student work and research work, and like basically introduce how they are interrelated to each other. So this is me. Yeah, and most of the stuff you can find from the website. It's soomeenhahm.com, and every single project that I have been involved are uploaded there. So if you are further interested in any detail, please have a look. Yeah, so our office is really interested in the way to bridge certain research agenda and architectural practice. So we are not really just interested in, I'm interested in making a proper architecture projects, but also if they are just merely for making spaces or like making a budget space, I think that's not really interesting. So there are lots of interest, a lot of like research interests that we are focusing on, but mostly related to the way of using computational technology, and especially in the way we design and start think about the conceptual spaces in the beginning. So focusing on the way of using simulations, text-based coding, ways to generate geometries through the control of agent-based materials, digital materials basically, and trying to bridge the kind of the gap between human controllable elements and something that can be also generated from using the computer power. So normally if you use object-oriented coding methods or particle-based simulations, there are lots of computer kind of generated moments, but also you need a lot of human control. So there is like really interesting negotiation between human controlled geometries and computer generated geometries, and we are kind of really interested in the kind of like finding an interesting moment in between. So here are some snapshots of some previous work. So the one you are seeing is a furniture installation, or this is for a work from the Bartlett and AA done with students, and some workshops that we have done. Yeah, so it's just a mix of a lot of different projects. I have a lot of videos today, so I'm not going to play everything because then I won't finish my lecture in 30 minutes. Yeah, but so maybe I will just skip through some videos, but maybe I will just play this one, finish it, and then for the rest, maybe I will skip a lot of videos. But yeah, so that's the basic kind of starting moment. So interested in computer generated geometries and looking at the ways to appreciate and interpret those into architectural spaces, and anything that we can translate into architecture or urban or physical geometry, basically our physical environment. So there are also some very commercial or like more pragmatic projects that we are involved, such as a lot of competitions like these. Normally we didn't win any of these, yeah, but we do work on these, just really trying to get some proper product. This one is an interior project that it's actually built in China, Qingdao. It's called High Sense Museum. If you happen to be in Qingdao, maybe you have heard of it, or maybe not. This one you have seen it. This one we just recently did a digital futures workshop in Shanghai, and also some installation or exhibition in Korea. And these are student work from Bartlett and AA and a visiting school. But main research agenda that we are recently focusing on is called Augmented Architect, really focusing on the ways to understand our future and our technological development towards augmented architect. By meaning that I'm also like writing a research proposal and papers regarding this. So I'm not just doing it for just fun. Yeah, I'm trying to really make sense out of all this. Basically, there is a book, but also a lot of scientists are arguing, or they also like say that current age, after the internet age, we are actually in the augmented age, where we are all using smartphones right now, right? So actually our memories, our brain is actually augmented. Our knowledge is augmented. We don't have to constrained by our physical brain power, isn't it? Yeah, that's so we are already like augmented cyborgs. But there are more and more like inevitable technologies such as smartphones will be with us in the future very soon. As if we are using smartphones, there will be a lot of different wearables and augmented machines that will be available for us. And we are really interested in what that means to us, to our designers and to architects as a designer. So we should really be in the very proactive position to really propose how these technologies will be actively or positively used. So after 2016, the Microsoft HoloLens have been commercialized. So this was the most, maybe the first really usable commercialized device that has been really released since 2016. And there will be more and more like cheaper and cheaper devices and better devices will be available for us. But still it's not that straightforward. It's a very heavy device. It's a bit expensive. It's around $2,000. And still, but there are lots of different interesting things are going on to really try to benefit our life. And these are some very, let's say, typical applications in warehouse and medical, and like this using of AR in this kind of field is considered to be something that is very appropriate, and it has a very bright market future. But as me, as an architect and as a designer, I'm really interested in like questioning how this will be applied to our field, right? So there has been a lot of development regarding digital fabrication over the last 10-something years, especially in ETH, ICD, also Bartlett, RMIT. There has been really interesting research have been going on to test and figuring out how much more complex geometry can be fabricated more meaningfully, instead of, for example, some very expensive or very complex, for example, very typically Zaha building could only be built with very specific technique and very highly expensive devices and technologies and technicians. Yeah, so there has been quite a lot of interesting projects and research to really go about this problem, to really create economic and more meaningful ways to create interesting spaces and structure. Because with the use of these technologies, like typically in SCI-Arc, we design like really creative, crazy geometries and buildings. But if you really come to think about it, there are very limited methods to build them, or they have to be very, very expensive. So I have been kind of educated in a way that like the understanding of the structural principle and those kind of things, although I'm not knowledgeable as an engineer or something, but those understanding is quite important in order to kind of we can, as a designer, can suggest something like crazy, but also like meaningful in terms of engineering and so on. So the question was, in our first few years of Bartlett teaching that the research together with Daniel Richard, Stefan Bassing, and Igor Pantic, we have been kind of really developing series of portfolios that use computer-generated geometries and finding a meaningful material methods to build them. So we were not really questioning whether this has to be using robots or 3D printers. We were like really looking for interesting and meaningful, let's say, ways of using materials. So for example, this is a really simple way of using balloon as mold and fabric sleeve and hardening it with maybe plaster or resin to create a really lightweight or woven structure. But this could have been a very meaningful or a ways to kind of rationally or execute these types of geometry. So there has been a lot of studies to find interesting ways of coupling this material system and algorithmic modeling processes. So as an example, this one, we have generated geometries, and there are some extraction and rationalizing geometry process, and then utilizing that to fabricate a one-to-one model. And even this one is pretty tall, much taller than a human, but we could have made it pretty fast, pretty low cost and lightweight. And if you build this big with 3D printing, it's super expensive, believe me. So we have also like this project similarly could have made this. And digitally we populated to find out a way to populate this to understand architectural potentials, and so on. So like populating more and more to find different ways to populate and understand them as architectural elements such as staircase, column, wall, and so on. So our that kind of material-based agenda or research has been developed for a few years before 2016. So I had a chance to branch out from that unit to develop an augmented reality based unit to really try to bridge this gap between loose generated complex geometry in digital and the physical model. Because before that, before we have augmented reality device, there was no really a way to translate it. Because it's very difficult to print out any blueprint to kind of position things in precise positions and so on. So it's still a big agenda. For example, these are different material processes that we have studied, but I'm gonna skip this video. But this video showcases the studies that we have done and developed with this focus on the use of augmented reality technology. So after few experiments and research, we also realized the most interesting, let's say, aspect of the use of AR is the way that we can always change and communicate with digital vision or computer decision with human decision. So there must be a more efficient and interactive ways of communicating with computer calculation and human decision. So AR is really easy for us to just follow a complex model in real position and fabricate them. But as a research, we are really proposing how we can also feed back the changes that we make in reality and feed that back to computer again, and let the computer to regenerate the next solution for us, and so on. And these videos are actually a showcase of that. And this is actually involves a bit more complex complexity, because computer needs to have a good, like, real physical eyes sensors to understand what's going on in reality. And the computer calculation needs to be smart enough so they can make real-time suggestions and changes. Like, so this agenda is still ongoing. So there's no like real actual solution. But for example, this one, you can see that we are using these these are a lot of cameras. They are called motion capturing system, where you can see a lot from like movie industry, where like people are acting like a monkey with a suit or like some sensors on their black suit. Like so, all of these kind of technologies are important and can be utilized to communicate with computers. So there are lots of side agenda that still needs to be resolved, but of course, most interesting and straightforward thing is that we can create this kind of very complex geometries very easily, very fast, comparable to any robotic process or CNCing process or 3D printing. Of course, the one side note is that this augmented making using like very much like hand, if it relies a lot with hand crafting, they need to be, we have to use certain, we have to choose certain geometric or aesthetic that can absorb, that has high tolerance in their design. For example, like things are curvy, fuzzy, they normally allow bigger and higher error tolerances. And normally these kind of processes works much better with these types of making, because at the end of the day, it's made by human hands. They are not 100% precise. So we also, like after a lot of tests, we realized that like precise or like some very like angled geometries are not very good for this kind of system, unless the parts are made by machine. But that are actually against our agenda a little bit. So anyways, so these are the agenda that we have been really researched and developed, like a lot of different student portfolios around this. We also were running a lot of like international workshops, short workshops, to like really test it with outside people. Even we say it's a visiting school, it's actually for it's open for public. So it was kind of like, yeah, and we also kind of were interested in looking at the issues of future cities and how new technologies will affect in our urban environment in the future in a bigger sense. So not only focusing on the fabrication aspect. But anyways, the previous part were about academic work, and the most milestone project I consider is this project that we managed to do in Tallinn, Estonia, Tallinn Architecture Biennale. And we used the same idea, same agenda, using crafting process and augmented reality assisted process to build this complex geometry. And these are the teams of designers. And the technique we chose to use is seam bending. So this is a very traditional seam bending process. You normally need a very expensive one-off mold to bend one huge piece like this. But we actually hacked this process. So we used AR to, I'm gonna skip this. I'm gonna skip a little bit. And for this project, we use this way of like connected really long pieces together and steam. The reason we steam it is to make the wood stop. And while it's hot and wet, we can bend it. So the way we could really hack is the mold. You can see here. So the mold is actually positioned in using AR. So every single mold was different, and they can bend different curvature. So we had around 140 something curvature, and every single curvature was bent with on different formwork. Unlike the YouTube tutorial that you have just seen, we didn't have to build 150 molds to build 150 curvature. We could use just this kind of like flexible systems to create quite, we can say it's quite sustainable in terms of that we didn't have to use any scaffold. It's a reusable molding system. So as you saw, the brackets are also bent by hand. The assembly was also done with AR, and so on. So this is still there in Tallinn, but I think it's going to be demolished soon for the next one. Yeah, but I think this was the first, the most complete structure, let's say, done by AR, and I think for us it was a really milestone project. And after that, we just finished a similar project in SCI-Arc with SCI-Arc students, and for a SCI-Arc gallery exhibition. It's open until this week. So if you want to see this in person, if you are in LA, welcome to have a look. But yeah, so this is the design. The most important development of this one compared to the previous pavilion is design-wise, we are trying to develop a steam bending wood structure that can create proper inhabitable enclosed spaces. So we try to make it into a layered system. We can also have a window. It's a small part of a bigger inhabitable space, so it's not like fully doesn't fully kind of explains every single aspect of architectural element, but at least I can see how we are trying to see the layers are accommodating window details or enclosure, envelope, and insulation. These are the process. It's very similar. So the making process I'm going to keep a little bit, but as you can see here, what we really tried this time is to bend around 8 to 10 pieces in same mold. So unlike steampunk pavilion, we were bending one piece on one frame. But this time we bent few frames together. So it was a little bit more work, but yeah, actually this way we were like using the bracket as the mold itself for the rest of the pieces, and then we could manage to make them into few parts and assemble them as chunks, so we can actually move it. We can disassemble it and move it as parts. So this is how we were making it, and I'm going to skip it a little bit. Yeah, so you can, let me show this. So you can see that we have like 3 pieces together. They were connected together, and then we bent the rest. So there was a little bit more assembling process, and then these were then separated into 3 pieces, moved in, and then there were only few connections needed. And then like around one day we could connect it. And then, yeah, I hope I can also keep it after the exhibition, move it somewhere. Yeah, I think almost out of time, but so I'm going to just go through a little bit. So there's also this project that we did in Canada. This one is what we are currently doing right now in Korea. But I think as you are coming to SCI-Arc, I thought maybe you will be interested in knowing. So all of, like, I have all this agenda behind. So what do you do with your studios or seminars? So there are, as I said, there are different agendas behind. So if we are talking about making with AR, firstly we need to have some more interesting computer generated geometries behind, because otherwise you can just make and build without AR. So one agenda is to really looking at the ways to use computer coding and ways to generate assemblies and geometries, and translating these complex geometries into architectural spaces. I think it's more like a sculpturing process, yeah, but it's an interesting, most interesting process that you are controlling the assemblies of geometries using some kind of manipulation of coding or geometries, but eventually you as a human, you need to understand the space, you need to direct the spaces into architecturally usable spaces. So these kind of exercises show how these processes are done, and then you can create really crazy or interesting buildings. And another kind of agenda is, these are like similar ideas using like a gaming process to assemble different spaces together to create interconnected like urban space. And another kind of agenda is to also a similar idea to have really interesting geometries to create cities, cityscapes, and everything. But also, we are really also focusing on how we tell the stories. And in this case, we were using game engine to actually design the camera passes. And when you are at a certain point, you can also animate certain elements. You can design the UI, so you actually can interact with the game. You can click on something, and you can hear some sound, and all these are actually part of the agenda. So you can use a creative media to tell the story of your architecture or of your proposal. So here are, this is another project that our students did last year, Vipagi. So they were 2B, but I think as 2B they were like, they really enjoyed the process. So they could have like really made quite intricate architectural spaces. Yeah, and in terms of seminars, we do two kinds of seminars. One is really focusing on the development of AR app on your phone or with HoloLens. So I'm running a little bit late. Yeah, but I'm finishing. Yeah, so you can design an app and really propose a way for us to experience the city and spaces in a different way, like a bit more immersive, and trying to ask a way for us to answer what does it mean by experiencing a city. And another kind of agenda is to look at the making process. So we have run this during pandemic. So we asked students to develop an app, completely developed from scratch, and design and make a actual physical chair in their house. Like some of them made chairs, some of them made lights, but depending on their choice of material. So this student used simulation to design a lighting structure and actually make it. So it was a seminar. So this is a bit more interesting to me. Like it involves also app design and making. So it's quite exciting. So yeah, so making this kind of video is the final output is the process video, of course. So finally, I'm doing an elective seminar this term. It's going to be using the steam bending process, and you will be doing similarly like app design and produce a furniture scale piece with steam bending process. And yeah, if you are interested, then you can apply for the seminar. And that's it for today. Yeah, and if you are more interested, then you can check out my Instagram and the website. All right, thank you.
Thank you so much, Soomeen. That was beautiful. I see some clappy hands. So nice to see all the work. Do you have time for a few questions if anyone has a question?
I have a question.
Yeah.
So like you use a lot of simulations in your design. So how do you like take those simulations and then turn them into like a design you can control? Like how do you take control of the simulation?
So I think, like for example, particle simulation is something I kind of choose to use sometimes, but mostly simulation is not something I'm very much interested in. I'm more interested in agent-based coding. So this kind of coding, basically, like you can code a certain rules for each agent, and you like there are lots of population of these agents, like birds flocking or like a lot of ants, like it's not like bugs, you know, like so you can control these kind of more digital robots, so you can gain a lot of control. So it's a bit different from physical simulation. So simulations have a little bit less control because they are not smart agents. Yeah, but they're interesting geometries, so we kind of sometimes choose to use. Yeah.
Yeah. Okay, cool. That makes sense. Thanks. Very interesting. I love your work.
Thank you.
Can I ask a question?
Yes, please.
Hi. So very amazing work. Thank you. And so I have a question regarding, so among the works you show us, there are several ones that are physicalized, there are several ones remained digitalized. So what's the criteria you guys usually pick for the one you eventually ended into physicalization? Like, is it like the formal aspect of it or more like functional, structural?
I see. That's a very good question. Thank you.
Thank you.
So, for example, if we know that it's or like in the beginning, if we know it's not going to be made, we try to do something more crazy. Yeah. So of course, like you don't have to really deal with actual load, you know, like that's really stupid if you are not gonna make it, but you don't try to be more creative, isn't it? So in those cases, maybe we choose to explore some more spatial potentials or looking at different ways to explore different aspects of different things. For example, maybe one project maybe can explore ways to use this algorithm to control, to create, maybe sometimes it has to be a chair or a table or it has to be a space. So it has like different architectural agenda. Then yeah, you try to resolve that. So there are lots of different processes, but those ones that has to be made, it has some more like criteria that we have to choose from some kind of, we have to start from some kind of material understanding. So it's mostly those projects that we fabricate, it's highly based on the understanding of how material works. Thank you.
Thank you. That answered my question. Thanks.
Thank you. Oh my God.
Okay.
Cool.
No
I
more
have a
questions.
question.
Oh, one more.
Hi, Soomeen. Sorry, my camera's off. Whenever I turn it on, Zoom just crashes. So, thank you for sharing your work. Can you talk a little bit more about, I guess, like your process? Because it seems like, so you design the actual like space and like materials and everything, right? And it seems like there's also like a big like emphasis on like the design of like the creation, like how you're going to build it, right? Could you talk about like what comes first and like kind of like the transition from like designing the building or like the pavilion to like the design of like the creation of the thing, if that makes sense?
I see. I think maybe if I understand correctly, maybe you're asking where is the tension lies in between the choice of material and choice of design creativity. And I think maybe because I'm not a engineer, so probably I could have become a little bit more crazy with geometries. Yeah. But anything, I think the main wheel, or like the main goal of everything, even if it's a fabricated project or digital project, it has to be visually pleasing and really spatially or experientially like kind of overwhelming, or something that really touches in terms of visual experience or actual experience. So that is some kind of let's say main driver in the beginning. Yeah, that is a very personal choice, but it's also something that I learned a lot from my my study and my previous work from Daha, because in Daha, when we are building or making things, making spaces, it's very much about like visual experience. Yeah. So of course, there are like we don't have to deal with any structure issue because the engineers will deal with it, right? But in my actual case, it's not the case. So I'm trying to bridge that gap between, so because yeah, we are not Zaha, like they are like a big brand. We are not gonna get those clients. Yeah, but I think we still have to have that kind of real of creating really interesting spatial experience and like visual experience. So if you see like all the Zaha projects, like most of the time you cannot get the geometries in one view. You have to like see and travel, like your eyes need to travel around to really understand the full geometry. And that kind of visual experience is quite stunning. And I think many of my work has been influenced by that. Yeah.
Great, thank you. Looking forward to meet you in person.
Thank you. Yeah, looking forward to.
Do you have time for one more, maybe?
Yes, please.
All right. So just to begin, I love that presentation. Your work is amazing looking. You talked about like programming rules-based systems, like coding that like you can create like emergent phenomena simulated. And I guess I was thinking about how it seems like these like complex emergent systems, like how like, you know, like atoms turn into molecules and then like you get all of life and stuff like that. Like you can't always explain exactly how they work. They're kind of like a black box sometimes that like can have like they're not deterministic. Would you say that is true? And like, what do you think it means for architects to not like exactly know how our forms came to be?
Yeah, I think this kind of process, there is, as you say, the interesting aspect is that I'm designing, but without knowing the final geometry. Yeah, the result. Yeah. But actually by absorbing it, it kind of emerges into something. And there is a moment that you feel like you decide as a human, as a designer, to value which moment is valuable for certain architectural use. Then, so there is this kind of communication and negotiation between human and computer algorithm.
That's like you're guiding each other basically, like you're guiding the process in like a direction, but you're not exactly sure like where it's gonna go.
Yeah, basically you give a certain criteria and you absorb it, and you absorb it, and you also like sometimes you accept something, you sometimes make more changes. Yeah, so it's not a closed linear process. It's more like a learning and looking, trying and erroring process. So I think it's quite difficult to just determine what comes first. Yeah, but I think it's an enjoyable process. But I think in the future that like if you are more advanced, if I'm not, but for example, the AI, artificial intelligence, are more tend to give you a right solution. So you just give a lot of criteria, maybe it gives you the best solution. But this process I'm taking is not that smart. It's more like not really trying to let the computer to take full control, but also try to find out ways to creatively use computer tools. So just beyond just modeling, top-down making. Yeah. So it's basically a communication between bottom-up and top-down.
Great, that was awesome. Thank you so much.
Thank
We
you.
have time for one more. Yeah. One more?
Yeah.
Okay. So I think it's interesting. I mean, you have kind of a captive audience. I think as architects, we can all appreciate your work very much. But something I'm interested in is if in the transition from like Zaha, where they sort of have, you know, creative freedom to sort of guide the clients into some sort of interesting, you know, visual proposal. In your own practice, have you been developing, you know, a vocabulary or a pitch that you sort of work with clients to understand where your vision is at and what kind of value it's going to bring them?
Yeah, so basically, I think that is also my dilemma, and it's a dilemma for like more post practices like me and maybe a very near future of you guys. It's if you don't have a clear portfolio and agenda, you can never convince anybody to do something you want. Yeah. And in order to not fall for that, so like, you know, if a client wants to build a house and like, if I don't have any agenda, then I just have to build something that is just most modern and like clear and most budget practical. Yeah, but of course we want to make something more meaningful, budget meaningful as well, but you have to have something to really convince somebody. So I think I have been more focusing on doing less client-oriented projects yet, but which is not very financially good. So yeah, I still want to do something more like commercial that makes money, but like I will probably wait until there are some clients really appreciate certain things. But it's very difficult to convince something, even if I have few things already built, but it's still not a most practical and budget house solution, you know, like it's not really good for every single client. So I'm sure there will be a good match in the future somehow, but I'm not like very rushing to kind of reach that moment yet, but like really focusing on trying to develop few more projects that can convince more people that this is meaningful things to really try. Yeah, to spend money on.
Thank you for sharing.
Thank you.
Okay, a big round of applause. Thank you so much, Soomeen. That was absolutely beautiful. And your generosity of comments was great. So, thank you.
Yeah, thank you very much. Thank you.
I'll see everyone tomorrow. I'll let Kumaran take over on group 4. Bye, everyone. Thank you.